Okay, this is a really interesting integral from one of my subscribers, the integral of ln of square root of x plus 1 plus square root of x. I will demonstrate his solution for you guys. Unfortunately, I could not find his email nor his comment anymore. And I did print this out a long time ago. I just haven't had a chance to present this for you guys. But anyway, please pause the video and try this first. Okay, so once again, I'm going to present his solution for you guys, and maybe you can leave a comment down below and let us know that how did you go do it. I'm sorry that I could not find your email and your comment anymore, and hopefully you are still watching my video and you know that I'm actually presenting this for you and for my subscribers. So yeah, thank you for the solution. Anyway, here is what we notice. We have two things inside of the ln, and they are just off by one, right? Kind of. Okay, and when they are kind of off by one, this kind of calls out the substitution, because for example, when we know secant and tangent square and secant square, they are off by one, and instead of an integral, we really like to have tangent and secant together because they get along really well, right? And in fact, when you put tangent and secant inside of ln, that's actually really cool as well. So now here is the approach. First of all, let's go ahead and let square root of x to be tangent theta. And then we'll work everything in the theta world first, okay? Look at this and square both sides. We get x is equal to tangent square theta. And of course, we can differentiate both sides so we can get a dx, right? So dx will be bring the 2 to the front and then keep the tangent as of now. And then multiply by the derivative tangent theta, which is secant square theta. And of course, we are talking about the theta world, put down a d theta. Now, look at this right here. Let's add 1 on both sides because I want to get to square root of x plus 1. X plus 1, this is pretty much tangent square theta plus 1. And this right here is exactly secant square theta. And now we'll just take the square root right here, here, and here. And we are saying that this is indeed just secant theta. And of course, we don't worry about the absolute value when we're doing this kind of integration. So just focus on everything is being positive as of now, okay? Anyway, let's put this into the theta world. So we are going to have the integral, and we still have the ln, of course. And this right here is secant theta, so let's have this right here. And then we add square root of x, which is tangent theta, so let's put that down right here. And then dx, it's just all that, so let's put that down. This is just going to be 2 tangent theta secant square theta d theta. Okay, now let's take a look right here carefully. Did we make the integral nicer or worse? It has a lot of things now, huh? But the good thing is that, notice, this part is what we know. If you integrate ln, okay, we cannot integrate that. But if you differentiate ln of secant theta plus tangent theta, when you differentiate this, you get nice d equal to secant theta, right? So we can totally differentiate this nice d. And this part, we can totally just integrate that because it came from the derivative of that. So we can totally integrate that. So we are going to try to use integration by parts in this part right here, okay? And by the way, integration by parts and the DI method, they are the same thing. DI method is just an easier way to set up integration by parts without using the UDV or other things, okay? But anyway, let me just do it right here for you guys. Let's put on the D and then the I and the plus minus on the side. Let's differentiate that, which is ln of secant theta plus tangent theta. And then we are going to integrate this. 2 tangent theta secant square theta. The integral of this, you can let u equal to tangent theta, or you can just look back, right? Because this is the derivative of that. So when you integrate this, you pretty much just get that, right? So the integral of this is just tangent square theta. So nice. When you differentiate this, you get secant theta. And perhaps the easier way to notice this relationship is when you integrate secant theta, you get that for the standard result, okay? Anyway, we'll continue. Remember, the product of the diagonal is the first part of the answer. And we stopped it right here because if you want to keep going, I think the expression is going to be bigger and bigger. And the truth is, we can integrate the product of this rule already. So that's why we stopped it. Anyway, we will just have this times that, and it's positive, so let's put that down. That's the first part of the answer. And when we multiply this row, keep in mind, the product of a row, it's still an integral. So that's the minus integral, so let's put this down. This is minus the integral, this times that. So we have secant theta times tangent square theta d theta, like that. This part is done. How about this now? Well, we notice that tangent square theta, this right here is secant square theta minus 1, right? Okay, so what we can do is we can just distribute this right here, and then when you do secant times secant square, you get secant to the third power. That's actually a standard result as well, and then secant to the first power, we should also know that. So let's just do that. And I'm just going to write this down right here for you guys. First of all, we have the minus, and of course that's the same right here. Let's look at this times that, which is secant to the third power, and that's still integral. So this is the integral secant to the third power theta, and let's close that with d theta right here. And then this is minus times another minus, we have plus, and that's still integral secant times 1, which is secant to the first power, and let's close this integral. Okay? All right, so now this is what we have, and let's focus on the result of this and the result of that. And that's pretty much it. This right here, now let me just write it down. Minus. Now, this is a standard result or a standard problem, or you can look at my description. I have done this video already for you guys. But anyway, the answer for this is 1/2 secant theta tangent theta plus 1/2 ln absolute value secant theta plus tangent theta. I told you secant and tangent, they get along really well with each other, right? I put on parentheses. This right here is just the result for that. Now, this right here, we add. This is the integral of secant theta. This is the integral of secant to the third power theta. But notice, when you multiply the negative inside, you get negative 1/2 of this. And this is positive 1 of the same thing. So negative 1/2 plus positive 1/2, so negative 1/2 plus 1 is positive 1/2, right? So you can combine like terms. I'll just put this down, this and that, you get positive 1/2. So positive 1/2 ln. Okay, oh my god. We're done with the integration. Now, it's just a matter of that. We go back to the right world. Okay, so now, how can we go back to the x world? Well, we know that x is equal to this, or tangent theta is equal to that, right? And of course, this right here was equal to secant theta, which is equal to that. Pretty clear. So we can just put everything in. So just by looking at all these ingredients that we already have. Finally, let's see. Tangent square theta is just nicely equal to x times ln of secant theta, which is square root of x plus 1. Okay? And then plus tangent theta, which is nicely equal to square root of x. Okay? And then minus 1/2 secant theta, which is, well, just that again, square root of x plus 1. Tangent theta is square root of x, and then this is plus 1/2 ln. We don't need the absolute value, you will see. But let me just write this down for you guys first. Secant theta is square root of x plus 1, and you add tangent theta is square root of x. This is always positive. You add something that's always positive, so now you can just put down parentheses. This is it. Okay? And of course, if you would like, you can just multiply this inside and say this is square root of x squared plus x, but I will leave that to you because we are done already. Finally, put down the plus c. Pretty cool, huh? And next time when I teach Cal 2, I really want to put this on my final exam maybe.